Okay, here's the long ago promised test for practice. So starting off, cell potential of the following reaction. So we have to look at what's happening. So we have NO going to NO3, and we have dichromate going to chromium. So we have to find those cell potentials. So let's find NO first. NO to NO3. That's 0.96. And the dichromate's right there. 1.33. Now, when given a reaction, always trust the reaction. Always trust the reaction. Sure, it'd be great if it's spontaneous, but always trust the reaction. So chromium, it's always E reduction minus E oxidation. But one way to think about it is E identical minus E opposite. So chromium, we start with dichromate and go to chromium. So that is identical. The nitrate is on the left, NO is on the right. So that's the opposite of how we see up here. So opposite. So 1.33 minus 0.96, the only possibility is B. What temperature is this spontaneous? The temperature which sign is spontaneous is T equals delta H over delta S times 1,000 to turn kilojoules into joules. This reaction, delta H, difference between those two numbers, negative 241.8 minus a negative 285.8. Sound like 44. Positive 44. And the difference between the S's, 188.8 minus 70.0, and like 118.8. That's joules per mole Kelvin, and that's kilojoules per Kelvin. So 44 times 1,000 divided by 118.8 will give us our temperature in Kelvin. That gives us 370.4. Close enough to 373, which is 100 degrees Celsius. Okay, this one, that's a bad one. The reaction's always going like this. In this equation, this is a Nernst problem. Nernst problem. E equals E naught plus RT over NF ln Q. Well, our E naught is 0 because it's the same reaction going as coming. But our Q, or R, so you have equals 8.314, that's our R, times T, 298, over our electrons, which is 2, Faraday's, which is 96485. The hard part right here, the ln Q, products over reactants. So that's H plus squared over H2 times H2 over H plus squared. Unfortunately, we have to do the pHs. Turn the pHs back into the H plus is equal to the 10 to the negative pH. So plugging that in, 8.31. Well, let's see, what's all that? 8.314 times 298 divided by 2 divided by Faraday. Sound like 0.0128 natural log of 10 to the negative 7 squared, or 1, over something. This is 6.3 times 10 to the negative 3rd squared. So something like that should be minus. So it makes it positive 0.284. 0.284. It's a nasty one. Don't worry about that guy on the next test. We won't have a Nernst. I promise that already. What is the Gibbs free energy of this reaction? Well, Gibbs is equal to delta H minus T delta S divided by 1,000. So products. So delta H is products minus reactants. So negative 240.1 times 2 minus 230 times 2 plus 0 minus the reactants, which is just sodium times 0 times 2, and water 285.8 times 2. So delta H 230 times 2 plus 285.8 times 2. Delta H is on like negative 368.6. And delta S, we have to do the same thing. Do the same thing except with more values. 59 times 2, negative 10.9 times 2, 130.7 minus, let's see, 51.3 times 2, and 70, times 2. So 59 times 2 times 2, 130.7. It's 51.3 times 2 minus 70 times 2. So, and B is 15.7 joule per mole. So plugging this in, negative 368.7 minus negative 298 times negative 15.7 all over 1,000. You get sound like 364. So it's close to your delta H, but a little bit off. Right along, balance the following equation. So step 1, split it up. Step 2, balance the elements. Step 3, balance the oxygens. Step 4, balance the hydrogens. 3 times 2 is 6, so we need 6H plus. 2 times 1 is 2, we have 2H plus. Balance the charge. 6 plus 0, need 6 electrons over there. 2 plus 0, you need 2 electrons right here. Last step before we combine is to make the electrons the same. So 3, so you have 3 waters, 3 magnesiums, 3 magnesium oxides, and 6 protons, 6 electrons. I'm going to cancel out the 6 electrons, 6 protons, and the 3 waters. So my final equation when I put them together is 3Mg Fe2O3 goes to 3MgO and 2Fe. What would the Ks be for silver chloride be at negative 15? Step 1, what is the temperature at negative 15 in Kelvin? 258 K. So delta G equals negative RT ln K. About 1,000 because of units, kilojoules to joules. So step 1 is finding delta G. Not hard, but annoying. AgCl goes to Ag plus and Cl minus. So delta H equals 105.6, negative 167.2, all minus a negative 127. 6, 167.2. So you get positive 65.4. Delta S, equally easy to calculate. 56.5 and 72.7 minus 96.3. 32.9. So delta G, which we kind of need, but don't kind of need, it'd be 65.4 minus 258 times 32.9 divided by 1,000. It's 258 times. So we get delta G is something like 56.91. 56.91 kilojoules. So plugging this back in. So 56.91 times negative 1,000 divided by 8.314 and 258. All that equals ln K. ln K, I'm running out of room, ln K is equal to negative 26.5. You take the inverse log and you get A. Take the inverse log, you get A. That one is a brutal one because I add 2 steps into this. You have to find delta G, then you have to find K. Okay, what is the Gibbs free energy of this reaction? Notice, I do not give you any table. So I have to use my table, I have to use E cell. when there's no table, use E cell. So 2 peroxides go into oxygen and water. So here's peroxide goes into water. So one of these is 1.77. The other guy, oxygen goes to peroxide, 0.68. So E cell is going to be 1.77 minus 0.68. Give us 109. Well, delta G is equal to negative NFE by 1,000. So at N, we can look at our 2 reactions to see N is 2. So negative 2 times 96485 times 109 divided by 1,000. You get negative 208 or close enough to that. Okay, calculate cell potential for the following galvanic cell. So it's galvanic, so it tells you what to look for. Cobalt, copper. So using that, you can always tell where to look. Cobalt. We want cobalt 2 solid to cobalt 2. Copper 2 to copper solid. So here's the copper 2 to copper solid. .34. And now where's the cobalt? Way down there, cobalt. Negative 0.28. It was a galvanic cell, so this has to be positive. But 3.4 minus 0.28 minus a negative 0.28 gives you positive 0.62, which is answer C. This is from the nuclear chemistry chapter. The half-life of carbon-14 is 5,730 years old. And the Dead Sea Scrolls are 2,429 years ago. How much carbon-14 should be left? So ln2 over the half-life is going to give you your K. ln2 over T1/2 equals K. That's a half-life equation. And for these nuclear reactions, a K is a very, very small thing. 968. And the equation ln would be A over A sub T equals negative KT. Well, ln of A over A sub T is going to be equal to negative 0.000120968 times my 2,429. I multiply those, 2,429. And then I take the inverse log. Inverse log, that would get this ratio. Multiply by 100 to get into percent, so it's 74.5%, which makes sense because it's not even a full half-life. It's a little bit over a half of a half-life, but not a full one. Okay, what is the voltage of this? So you can go delta G equals negative NFE. But first you have to find delta G. So you have products negative 408.32 times 2 minus negative 289.91 times 2. So our delta G is negative 236.82. So to get the E is going to be negative 236.82 times a negative 1,000 divided by N and F, 96485. The hardest part of this is finding the amount of electrons transferred. So here, oxygen is negative 2, oxygen is 0. How many electrons per oxygen? 2. How many oxygens? 3 times 2 is 6. So 2 times 6 is 12 electrons. So you get a voltage of 205.205. What is the Ka for this? Well, given the Ka, what is the Gibbs for this value? This is a good one. K and delta G for a reaction is equal to negative RT ln K, 1,000 units. So negative 8.314 times 298 divided by 1,000 times ln 6.2 times 10 to the negative 10. So you get a delta G of 52.5. Unfortunately, that is not our answer. That's the delta G of the reaction. So delta G for this guy, 52.5, is equal to products minus reactants. So H plus, which is 0, and 172, 4 minus our X, our unknown. So how do we do this? We're going to get X to this side and subtract 52 from 172. So the answer has to be something like 120, something like that. Number 12, at 350 Celsius, 350, which is at 273, is 623 Kelvin. 623 Kelvin. What is the delta S of the universe? Well, delta S of universe is equal to delta S minus delta H over T times 1,000 because of units. Delta H is products minus reactants, so negative 249.2 minus a negative 241.8. So negative 7.4. 7.4. And delta S is also products minus reactants. 98.3 plus 130.7 minus 188.8 and 145. So the entropy is going to be low and negative. The enthalpy will be low and negative 4.8. So plugging this back in, negative 4.8 minus a negative 7.4, but times 1,000 divided by 623. The entropy is 707. Though it's mildly spontaneous, but not too much. Okay. Determine the missing molecule from this radioactive equation. So this is once again another chapter 20 problem. The nuclear chemistry. The sum of these guys should add up. 239 plus 1, 240. 94 plus 0 is 94. That must equal to 3 times 1 is 3 plus x plus y plus 103 plus 40. So 40 plus y plus 0 is 94. So y has to be 54. 103 plus 3 is 106. 106 plus x has to equal 240. So that would have to be 134. 134. So 54 tells us what element it is. Look on the table. 54 is xenon. Can't really see, but xenon right here. 54. Now, balance and combine the following two half reactions. Okay. Mn2O3 goes to Mn2 plus. One half reaction. And Mn2O3 goes to MnO2. Step 1. Balance the manganeses. That's good. Step 2, balancing oxygens. 3 oxygens, we need 3 waters. 3 oxygens, 4 oxygens, we need 1 water. Balance the hydrogens. 2 H pluses, 6 H pluses, so, and now that has to have 2 electrons, and that has to have 6 electrons. We triple this up. 3 waters. Oh, wait, shoot. No, my bad. That doesn't have 6 electrons. Because that's 4 plus, and that's 6 plus. So that has to be 2 electrons. 2 electrons. It's 2 electrons because 6 plus, 2 times 2 is 4 plus. So this still gets the, so now when we combine these together, we get, let's cancel things out. 2 cancels there to give you 4. 1 cancels there to give us 2. We have 4H plus 2 Mn2O3s goes to 2 Mn2 pluses, 2 MnO2s, and 2 waters. Well, you can notice one thing. I can divide everything by 2. So this can simplify down to 2 protons, 1 permanganate, or 1 manganese, but that'd have to be 3. Goes to manganese, 1 manganese 2, and 1 manganese 4, and 1 water. Okay. Story of the chemist who dissolved the Nobel Prize to prevent theft of Germans in circa WW2. The metal weighs 175 grams prior to being dissolved, gold 3 plus. You can run at 30 amps. How long would it take to electroplate the gold? So mass is equal to current times time times molar mass over NF. My current is 30. N, because it's 3 plus, is 3. The mass is 175. Faraday's is Faraday's, and the molar mass of gold is about 197. You can't reread it on the screen, but it's 197. So rearranging, time is equal to mass times NF over IMM. So 175 times 3 times Faraday's divided by 30 divided by 197. And this will give us time in seconds. You get some really big number, blah, blah, blah. 8, 5, 7, 1. That's not an answer. So how do we deal with this? We divide by 60 to turn it into minutes. 142, 143, still not good. Divide again. Get to hours. 2.38 rounds to 2.4. It would take 2.4 hours to fully deposit that. Which chemical reaction shows an increase in entropy? We're going to ignore solids, liquids, aqueous. We want the number of gas to increase, to have an increase in entropy. We have 2, we have 1, not an increase. We have 1 plus 2, 3, 1, and we can ignore the liquid. We ignore the solid. 3 goes to 0. 0 goes to 1. 0 goes to 1. What is the cell potential of the following reaction? So once again, reaction, follow the reaction. Gold, 5. Lead, unfortunately, though, lead is the identical one and the opposite is our gold. So our answer is A, 1.63. Another nuclear chemistry one. 186 plus 1 over 74 and 0. So 187 and 75 and 74 on the left equals 0 plus x and y minus 1. So our x must be 187. But our y, 74 equals y minus 1. So this has to be 75. 75. Element 75 is rhenium. So the answer is rhenium 187. Looking at the combustion of ethanol, the source of Gibbs, what is the Gibbs at 600 Kelvin? Delta H is given. Delta S is products minus reactants. So delta S is 188.8 times 3 plus 213.8 times 2 minus 205.2 times 3 and 160.7. So entropy 217.7. So delta G is going to be negative 1367 minus 600 times 217.7 divided by 1,000. 1497.6, which rounds to 1498. Last one. What reaction occurs at the cathode? Well, which one is a reduction? Cathode is the reduction. So which of these are reductions? A is a reduction. B is a reduction. These guys are oxidations. So not those options. The electron, the cathode is the positive charge. So where is the electrons flowing to? They have to be flowing to the right. Electrons are going towards the cathode. So what element's on the right? Silver. Usually we write it oxidation on the left, reduction on the right. Anode, cathode. Reaction going blurp. Like that. Okay, that is the test. Long, drawn out, annoying, the test. Our test that we will have will not be nearly as long, but some of the same stuff will be on there, but no chapter 20 stuff.